Now let's try to understand the various parts of our program. So for that, we need to get into some syntactic details of Solidity. So let's analyze part by part. So the first thing you would see is comment. So comments in Solidity are given by two forward slashes, and you will give a license identifier. It is just for copyright purposes, but it won't throw an error if you avoid this line. If you avoid this line, it will show a warning. We have seen that earlier when we copy pasted our code. The next thing is very important because Solidity is part of Ethereum, right? Ethereum is constantly developing, so is Solidity. There are various versions of Solidity compiler already available. We have already seen that, right? When we copy pasted our code onto the Remix ID editor, the editor was trying to resolve the compiler version for usage. So that is specified over here. So we use the pragma solidity directive to specify the compiler version for our code. For purpose of understanding our code, I will just specify it in a brief way. So we will use the caret notation as well as three dotted notation. So the first section is the major version, then minor version, then the patch. So these are the three components of a compiler version identifier. So the major version is still 0 for all for the current Solidity compilers. Even the latest Solidity compilers, the major version is 0. So it means that the major revision has yet to come for Solidity. So it's a constantly growing language. So we will mostly play with this minor version patch. So the meaning of this caret is any version greater than 0.8.4 but less than 0.9.0. We can actually range from 0.8.4 to 0.9. So it actually tells a range for the minor version. Okay, so it means that if the compiler used is above 0.9.0, it means that this code may not give the expected result. Okay, so if you avoid this caret, what will happen is the compiler is to be exactly 0.8.4. So that's the meaning of this pragma directive. We will cover later when we delve deep into the Solidity parts. But for the purpose of understanding this code, the meaning of this line is any version greater than 0.8.4 but less than 0.9 is acceptable. Now, the next major thing is all the code that you write, it is encapsulated within this contract scope. Okay, so everything you write should be within this contract scope. So contract is a keyword used in Solidity to specify start of contract definition, and my contract is a contract name here. Whatever goes between these curly braces, it constitutes the sections or parts of a smart contract. So this is the primary encapsulation mechanism in any smart contract. The next thing is constructor. So yes, as in any other object-oriented programming language, an object of this contract is instantiated, the constructor triggers. What is actually instantiation regarding a contract? From the perspective of a contract, when the contract is deployed from your account or from anybody's account, at that time the constructor will be called. So that is actually the instantiation of this contract template, right? So constructor is just like a function definition. As you know, it will be triggered when instantiation of this contract or deployment of this contract happens. Usually constructors are used to initialize the state variables. You will see what state variables are. Those are actually variables defined within the contract that keeps track of the state of this contract. We have already seen that a contract is characterized by the code, the entire code, as well as the value of the state variables. So these two things are stored in the blockchain. All the values of the state variables are stored in the blockchain along with this entire smart contract code. So this is very crucial. You have to define the state variables carefully, otherwise it will consume so much of gas. Okay, so only define the required state variables over here. Rest of the things keep it off the blockchain. So that's the major design principle you have to follow. So here this code means that there are three state variables defined over here: value, a, and message. Value is of type boolean, a is of type int. So it's actually integer 256. Then message is of type string. Then note that apart from the data type specification, we have to actually specify the access specifier for state variables also. So state variables can be public or private. We will go deep into that. The next major thing is functions in smart contracts. So functions are actually the logic encapsulations. So apart from the state variables, you need to have functions to perform actions on the state variables. So note that the state variables as well as the functions are encapsulated within the main contract scope. Okay, so that is very important. If you write something out of scope, it is not part of the smart contract. Okay, so here the state variable used is x. It is unsigned integer 256. Then how will you define a function? You will define a function using function keyword followed by name of the function, then followed by the parenthesis list of parameters. Okay. Then apart from that, you should also specify the access specifier for the function. So here public means that anybody can call this function. That is other functions within this contract as well as people or addresses from outside this contract can also invoke this function. So let's see what this function does. So before that, see the structure of this function. Function keyword followed by function name, parenthesized list of parameters, then the access specifier followed by the scoping of its logic. Okay, so what is the logic over here? X, that is the state variable x, is assigned the value with underscore x. So underscore x is the parameter passed to this function. Okay, so essentially this function is a setter, that is, it will set the value for the state variable x.